All right, in this video, we're going to be continuing our wastewater calculations, and we're going to be looking at some grit chamber calculations. Now, we're going to be looking in this particular example at a grit channel. So remember, in wastewater, you've got all kinds of grit that's coming in from the collection system. Things like literal sand, eggshells, coffee grinds, all these kind of gritty items come in. Whether they should be there, that's another story. But when they come into our grit chamber, in this case, it's our grit channel, right, in our, say, our pretreatment. Imagine that when water enters into this channel, there's all kinds of grit all over the place. But what we're doing in this channel is we're slowing that water down. Say water was flowing, at least 2 feet per second in the collection system to keep that grit suspended. We're now going to slow it down, right? Say somewhere around like 1 foot per second. Slowing that velocity allows those bigger particles to settle out. So in the beginning here, we got a lot of grit. As that water continues to move in this direction, that grit slowly starts to settle out and starts to settle down. So by the time we get to the end of our channel here, most, if not all, of that grit has settled to the bottom. Right? Now, these various particles have what we call a settling rate. Right? And think about it, it's the rate, if we look at just one particle, it's the rate at which that particle settles to the bottom. Right? We care about that. If those particles settle very quickly, then this water is gonna be able to move a lot quicker through my grit channel. If these particles settle very slow, we're gonna have to move this water a lot more slowly through my grit channel to get it to settle to the bottom, right? And this settling rate is based on what we call Stokes' law. And we're not gonna cover Stokes' law, but it looks at particle size, the shape, the reactivity, it looks at the buoyancy, it looks at water, and takes in temperature, all these different factors. And so what we use in the wastewater field, oftentimes, we use a settling rate of 0.075 feet per second. Right? Pretty slow, right? 0.075 feet per second. That's going to be our settling rate. So one of the things we often want to know when we're looking at, say, this grit channel, we want to know our settling time, right? We want to know how much time it's going to take for a particle to settle from the top of our grit channel to the bottom, because the amount of time it requires to do this is going to tell us the length of our channel, the speed of our channel, the flow of water we can treat. It impacts all of that. So in this example, let's look at this channel here. Let's say this is a 2-foot tall channel that is 30 feet long. So when we talk about settling time, we know that our depth or height of our channel here is 2 feet. We are given the settling rate of 0.075, so we're going to divide that 2 feet by 0.075, and that's feet per second. So what do I have here? I basically have a detention time similar formula, right? Where detention time is equal to volume over flow, right? Where, say, volume was, cubic feet, and flow in this case would be cubic feet per second. When we divide out, we left with that time component, very similar to that detention time formula, is this settling time, right? We're still talking time. But what do I have here? Here I've got my depth, and I'm dividing that by my settling rate, or in this case, my velocity. So my feet divided by feet per second, what am I going to be left with? I'm going to be left with seconds, that time component, right? So now I take my calculator, I do that 2 divided by 0.075. What does that tell me? It tells me 26.666, we'll just say 0.67 seconds. This is the amount of time it takes for a particle at the top of this channel to settle to the bottom. So now let's think about that conceptually. Okay, it takes almost 27 seconds for a particle to settle. So what does that mean? It means that this grit, or this wastewater flow, needs to spend at least 27 seconds in my grit channel by the time it enters until it leaves. So with this information, we can decide on the size of our grit channel, the length, the height, We can decide on the amount of flow we can treat. It has an impact on all of those properties. Right? So let's just look at this example. We know we've got a length of our channel. We've got the depth of our channel. We know the settling time, how long it takes for a particle to settle. So now I want to calculate, well, given these parameters, this is the grit channel we got to work with. This is the settling rate of our particles. I want to know what's the maximum velocity that water can move through this channel given these parameters, right? So if you think about it, whether water spends 10 seconds here or a minute here, that has a dramatic impact about how many particles settle out, how much of that grit settles out. So if we want to be able to calculate length in this case, or sorry, not length, but velocity, we want to know what is the max velocity for our channel. We need to know the length of our channel, and we also need to divide that out by the time component, the amount of time that we need water to spend in our grit chamber. So in this case, velocity, right, is the length over time, just like we've done in any of these, right? The length in this case that we care about is the length of our channel, which is 30 feet. The time that we care about is we need water to spend at least 0.67 seconds in our channel in order to settle out all that grit from very top to very bottom. So that is our time component, 0.67 seconds. So now I pull out my handy dandy calculator. 30 divided by 26.67, and that gives me a maximum velocity of 1.1 feet per second. So let's think about this logically now, okay? This settling rate, we're using this sort of as a constant, right? This is how fast particles descend vertically just via the force of gravity. We slow the wastewater down, it starts to settle out. Based on the height or depth of our channel and the rate at which particles settle, we know it's going to take particles at the very top of this channel around 27 seconds to settle to the very bottom. Knowing how long it takes these particles to settle, we can say that, okay, in a 30-foot long window, we need that water to spend at least this 27 seconds there. So our length divided by time gives us 1.1 feet per second as our max velocity for this grit channel.